We say that y varies at a constant rate of change of m with respect to x if anytime x changes by some amount, y changes by a proportional amount. So the ratio of the change in y to the change in x is always equal to some constant number m. Now this ratio tells us that the change in y is always m times as large as the corresponding change in x. And written mathematically, that means that the change in y is m times as large as the change in x. So we can use this information to determine new values of y if we know a constant rate of change and we know a reference point. So let's look at an example of this. Let's assume that y varies at a constant rate of change with respect to x, and the constant rate of change of y with respect to x is 0.75. And let's assume that y equals 3 when x equals 1. This is enough information to determine the value of y given any value of x. So let's look at some specific examples. When x equals 5, we can determine the value of y. So what we'll do is do a little doodling to keep track of the quantities. So we'll graph x and y. We know that when x equals 1, y is equal to 3. Now, if x equals 5, we can imagine increasing from x equals 1 to x equals 5. So we can imagine x increasing from 1 to 5, represented by this blue vector. And what we know is this change in x can be computed as 5 minus 1, which equals 4. And given the constant rate of change, we know that y has to change by 0.75 times as much. So the change in y is 0.75 times as large as 4. And so this change in y is actually equal to 3. Now the new value of y, or the value of y when x equals 5, is found over here on the vertical axis. We can actually compute this value of y. We can think about this as starting at an initial value of y of 3, and y increased or changed by 3. So this new value of y is 3 plus delta y, which is equal to 6 because our change in y was 3. So when x equals 5, we can say that y is equal to 6. Now let's see what happened when x decreases away from 1. So let's look at what happens when x equals, let's say, negative 5. Again, if we draw a sketch of a graph to keep track of our quantities, we can plot x on the horizontal and y on the vertical. And again, we know that when x equals 1, y is equal to 3. So we have a reference point at 1, 3. Now if we look at when x is equal to negative 5, we can imagine x changing from 1, an initial value of 1, to a final value of negative 5. And this change in x is going to be equal to negative 5 minus 1, which is equal to negative 6. And we know that the corresponding change in y has to be 0.75 times as large. So this change in y is going to be delta y is equal to 0.75 times as large as delta x, which is equal to 0.75 times negative 6. Let's compute that value. So we see that this change in y is equal to negative 4.5. So what we know is that this final value of y has to be equal to our initial value of y, which was 3, plus however much y changed by. So the value of y started at 3 and changed by negative 4.5. And that tells us that the new value of y, or the value of y when x equals negative 5, must be equal to negative 1.5. Now we can always use this way of thinking to determine the value of y for any given value of x.